I was looking up at the stars the other night.
Oh, yeah.
Yeah, just having a classic existential crisis moment. You know, how it goes. And I had this thought about how we have these absolutely incredible telescopes now.
Mm-hmm. We can see billions of light years away.
Exactly. Billions. We've got maps of the universe that are honestly more detailed than maps of our own oceans at this point. But the thing is, we can't actually go there.
Right. It's the ultimate tease, isn't it? The universe is just staring us right in the face. But the physics of getting there is just, well, it's brutal.
It really is the ultimate look but don't touch scenario. Because you watch sci-fi movies and they just push a button right. Warp speed, hyperspace, whatever jump drive they use, and boom, they're in the Andromeda galaxy having lunch.
Yeah, the reality is a bit more disappointing.
Just a bit. You walk into a physics classroom and the professor basically slams a ruler on the desk and says, Einstein says absolutely not.
Or to be a little more specific, Einstein says, sure, you can go faster than light, provided you have a fuel tank the size of Jupiter filled with something that literally does not exist.
Ah, yes, the dreaded negative energy requirement. It is such a buzzkill. But what if, for everyone listening right now, what if that professor was wrong? Or maybe not wrong, but just didn't read the whole textbook.
That's what we're here to talk about.
Exactly, because for today's deep dive, we are unpacking a brand new paper that claims to have found a loophole. And not just a tiny theoretical loophole, but a massive engineered backdoor in the laws of physics. So I'm your host, and I'm joined by our resident physics expert to break this down.
Glad to be here. And it is a bold claim we're looking at today. The paper is dated February 16th, 2026. So this is bleeding edge stuff.
Fresh off the presses.
Exactly. It's titled Metric Engineering in a Fractal Universe, Formalizing the Nasanjargal Metric and the Scale Drive Mechanism.
Metric engineering in a fractal universe. I mean, that sounds like a vintage prog rock album.
It really does. But the author, Nasanjargal Nasanjargal, is dead serious.
Right. And the mission of this deep dive is to unpack exactly what he's proposing. Because if this researcher is right, we aren't just talking about building a faster rocket. We are talking about a completely different way of moving through reality itself.
We really are. We're moving from the era of Newtonian propulsion.
Which is basically what, just throwing fire out the back of a tin can to push yourself forward?
That's literally all it is. Throwing mass one way to go the other.
Yeah.
But this paper moves us into an era of manipulating space-time itself.
Yeah.
Nasanjargal is proposing a scale drive that actually bypasses the need for that impossible negative energy.
Okay, let's unpack this.
Yeah.
Because I feel like every few years, someone says they've cracked warp drive and then it turns out, oh, wait, they made a math error on page 4.
Right.
To understand why this is different, we really have to understand the barrier. Like, why is it so hard to go faster than light? We usually hear about the Alcubierre drive, right?
Right. Miguel Alcubierre, back in '94, really set the stage for this entire field. He proved that the math of general relativity technically allows for a warp bubble. The idea is you don't actually move the ship, you move the space around the ship.
So you scrunch up the space in front of you.
Contracting it, yeah.
Yeah.
And you expand the space behind you.
Like a surfer riding a wave. The surfer isn't paddling anymore. The wave is doing all the moving.
That's a great way to picture it. And inside that bubble, the ship is technically stationary. The crew feels zero G forces. It's an incredibly beautiful mathematical solution.
But there's a catch.
A massive catch. To make space expand and contract like that, general relativity says you need an energy density that is less than zero.
Less than zero. Which is what, like antimatter?
No antimatter has positive mass. It has normal gravity. Negative mass is what we call exotic matter. It's stuff that would literally fall up if you dropped it on Earth. It repels gravity.
Oh, wow. Yeah.
And as far as we know, it doesn't exist in the universe in any usable quantity. It violates what physicists call the weak energy condition.
Okay, so Alcubierre gave us the recipe for the perfect cake, but the main ingredient is -3 eggs.
That is the perfect analogy. The math totally works, but the ingredients are impossible.
Oh.
And that is exactly where the door has stayed shut for 30 years. Until Nasanjargal.
So how does this new paper get around the -3 eggs problem? Does he just find a way to ignore the rule?
No, he doesn't ignore it. He changes the entire game board. He argues that we've been using a limited model of gravity.
How so?
Well, most warp theories use standard Einsteinian general relativity. Nasanjargal is using a much more complex framework called Einstein-Cartan-Siyama-Kibble gravity, or ECSK for short.
ECSK. Sounds like a law firm that handles very expensive divorces. But seriously, why switch to this framework? What does ECSK have that standard Einstein gravity doesn't?
One word, torsion.
Torsion, like twisting.
Precisely. In standard general relativity, gravity is just curvature. Mass sits on the trampoline of space-time, and the trampoline bends down.
Yeah.
That's it, just curvature.
Right, the classic bowling ball on a mattress metaphor.
Exactly. But ECSK says space-time isn't just a simple sheet that bends. It has a microstructure that can actually twist. And this torsion, is directly mathematically connected to spin.
Spin, you mean like a pop spinning? Or are we talking quantum spin here?
Both in a way. Quantum spin is a fundamental property of matter. Nasanjargal's big insight is that if you can manipulate spin density, if you can get enough spin concentrated in the exact right way, you can generate torsion in the fabric of space-time itself.
Okay, I'm trying to visualize this. Standard gravity is the bowling ball sinking into the mattress. What is this torsion doing to the mattress?
Okay, imagine you have a wet towel.
Got it.
Standard gravity is just laying that towel over a rock. It curves to fit the rock. Torsion is grabbing both ends of that towel and wringing it out.
Oh, wow.
You're creating immense tension and compression in the fabric. You're fundamentally changing its local geometry without actually moving the towel across the room.
I see. So you're tightening the actual weave of reality itself.
Exactly. And here is the aha moment of the whole paper. Nasanjargal's math shows that this localized space-time torsion can create the exact necessary geometric repulsion to maintain a warp bubble.
Wait.
And he does it using positive energy.
Hold on. Are you saying he just deleted the requirement for negative energy? Because that's the one thing everyone says is totally impossible to get around.
He didn't delete it. He completely bypassed it. By using extreme spin to create torsion, he effectively mimics the geometric effects of negative energy.
That is wild.
He's using the twist of space-time to push the bubble open, rather than using negative mass to prop it open. It's a fundamental transition from mass-based warping to spin-based metric engineering.
That is incredibly clever, assuming the math holds up, of course. But let's look at the title of the paper again, because it mentions a fractal universe. We haven't touched on that at all yet. How does a fractal fit into a rocket engine?
Oh, this is my favorite part. This is where the paper goes from clever physics to just mind-bending cosmology. You know what a fractal is, right?
Yeah, like those trippy Zoom videos on the internet where the pattern just repeats forever. You zoom in on a triangle, and it's made of smaller triangles, which are made of smaller triangles.
Right, self-similarity at different scales. Nasanjargal posits that space-time itself is fractal. If you zoom in on what we think is smooth, empty space, it's not actually smooth. It has depth. It has structure that repeats at smaller and smaller scales.
Okay, so space isn't like a smooth hardwood floor. It's more like a shag carpet with infinite detail.
The shag carpet with infinite depth, yes. And this is crucial for how the drive operates. The paper introduces a mathematical concept called fractal depth, which they denote with the Greek letter Ci.
Fractal depth. It sounds like a metric for how much philosophical trouble you're in.
It might be. But in this context, think of it as a new physical coordinate. Usually we just have x, y, z in time. Nasanjargal adds a parameter for scale. The scale drive works by manipulating how deep the ship sits within this fractal structure.
So we aren't just moving across the universe, we are moving into the texture of it.
Exactly. The drive uses what's called a shift vector. Remember the moving walkway analogy we used earlier?
Right.
It uses that to modulate the ship's coordinate velocity based on this fractal depth. By changing the scale at which the ship physically interacts with the universe, they can effectively gear up their velocity without adding more kinetic energy in the traditional sense.
That's insane. It's like finding a shortcut in a video game by clipping through the wall, but he's mathematically formalized it.
That's a really good way to put it.
But I did see something in the paper about a shape function. It sounded like some kind of safety feature.
Oh, it is the most critical safety feature. It's denoted as F of R sub S. Imagine you have this bubble of modified fractal space where the ship is sitting, and outside is just normal flat space. You absolutely cannot have a hard edge between them.
Why not? What happens?
Because a hard edge in space-time geometry is basically a mathematical cliff. If you try to cross a discontinuity like that, the tidal forces become infinite, you would be ripped apart at the subatomic level. The shape function uses hyperbolic tangents to ensure metric continuity.
So it smooths the slope.
Yes, it creates a gentle mathematical ramp between the intense torsion inside the bubble and the flat space outside. It ensures that the transition is continuous. Without that shape function, the math breaks, and your multi-million-dollar spaceship becomes a microscopic debris field.
Okay, so we have the twist from the spin, and we have the fractal depths to give us our speed. But how do we actually generate the spin? Are we just building a giant gyroscope in the engine room?
Not quite. We're talking about High-frequency gravitational resonators, or HFGRs. These aren't mechanical flywheels spinning around. These are solid-state devices that generate extreme spin density at the quantum level, and they couple it directly to the vacuum torsion field.
Coupling to the vacuum torsion field. That sounds like we are grabbing the background static of the universe and using it for tire traction.
That is a surprisingly accurate description. The paper's master equation clearly shows that torsion is directly proportional to spin. You turn on these HFGR resonators, they vibrate the quantum vacuum at a specific frequency, and that vibration twists the local space-time, creating your bubble.
Okay, let's talk about what happens when you actually turn this thing on. Because whenever I hear twisting space-time and fractal depth, I immediately imagine there are a million ways this goes horribly wrong. The paper had a whole section called Scale Decoherence, and it sounded terrifying.
It is the absolute danger zone of this concept. Section 3 discusses scale decoherence and tidal safety.
Oh.
And honestly, if you look at the diagram in Figure 1, it is the stuff of aerospace engineering nightmares.
Yeah, I saw that. It explicitly used the word spaghettification, which is usually reserved for, falling into a supermassive black hole.
It's the exact same geometric principle. Imagine the drive engages, but it doesn't engage perfectly uniformly across the hull. Let's say the front of your ship enters fractal depth A, where the effective velocity is light speed, but the back of the ship is still sitting in fractal depth B, which is stationary.
Oh, no.
Yeah, you get a massive velocity gradient. The front of the ship leaves and the back of the ship stays. The vessel is instantly stretched into a stream of free atoms. The paper politely calls it a shearing zone.
So you don't just crash, you get turned into a really long, thin noodle of superheated plasma.
Instant catastrophic structural failure. To prevent this, Nasanjargal introduces something called the scale coherence field.
Which acts like what? A giant clamp?
Think of it like a pressurized hull in a deep-sea submarine. But instead of holding back water, it's holding back causality and geometry. This field enforces a strictly uniform fractal depth across every single atom of the vessel. It locks the entire ship into a single cohesive reference frame, so the whole thing moves as one solid unit.
So it's basically the keep your arms and legs inside the vehicle at all times field.
Basically, without the coherence field, the scale drive is just a very expensive, very fast suicide machine.
Okay, so let's say the coherence field works perfectly. We're in the bubble, we're moving way faster than light, we are completely safe from spaghettification. But now we hit the other classic sci-fi problem, navigation.
Right.
If I'm going faster than light, I physically can't see where I'm going. The light hasn't reached me.
You are absolutely flying blind. The paper calls this the navigational opacity problem. Think about the physics of it.
Yeah.
You are literally outrunning the light that is coming from the stars ahead of you.
So what? The windshield is just pitch black.
It's so much worse than black. The light that does manage to hit the front of your bubble gets massively Doppler shifted. The gentle, visible light from a distant star gets compressed into high-energy X-rays or gamma rays.
Good Lord.
You're flying into a blinding, highly radioactive void. Your optical sensors, your standard radar, your LiDAR, they're all completely useless at those speeds.
That is such a terrifying image. You're completely isolated inside this bubble moving at impossible speeds, and outside is just darkness and lethal radiation. How do you steer? How do you not just accidentally fly straight through a planet?
This is where the paper gets really, really exotic.
Yeah.
You don't look, you feel. They propose something called pilot wave interferometry.
Pilot waves, like from Bohmian quantum mechanics.
Exactly that. They suggest that instead of relying on photon standard light, the ship navigates by sensing the quantum potential of the surrounding universe.
Okay, you're going to have to explain that to me like I'm 5. Or maybe 12.
Okay, let's try this. Yeah. Imagine you're in a pitch black room. You can't see any of the furniture. But imagine you had a superpower where you could feel the slight gravitational pull of the sofa before your shin bumps into it. You can sense the fundamental presence of the matter without actually seeing it.
It's like a submarine using sonar.
Similar concept, but sonar uses physical sound waves bouncing off things. This uses the underlying quantum wave function of the universe itself. The ship's computer reconstructs a real-time star map, not by looking at the glowing stars, but by reading the microscopic ripples their mass makes in the quantum field.
That is incredibly spooky. It's literally navigating using the Force. Reach out with your feelings, Luke.
It effectively is. They are sensing the gravitational and quantum shape of the galaxy ahead of them to plot a safe course, completely bypassing the optical light barrier.
Just when I think I have a handle on this paper, it gets weirder. Okay, so we have the twist engine, we have the safety bubble, we have the spooky quantum radar. Now comes the part that usually kills every single one of these theoretical ideas. The energy bill.
Ah, yes, the thermodynamics.
You said earlier that the old Alcubierre drive needed a Jupiter-sized fuel tank. What does this new scale drive actually need?
This is the massive efficiency leap. This right here is why physicists are actually talking about this paper. Section 5 deals entirely with resonant impedance matching.
Resonance, I know that term. That's like pushing a kid on a swing, right?
That is the perfect physics analogy. If you push a child on a swing at just random times, you just wobble them around, it takes a ton of energy to get them to go high.
Okay.
But if you push at the exact right moment as the swing comes back,
Just a tiny push makes them go super high.
exactly, that is resonance. Nasanjargal claims the scale drive doesn't just try to brute force the vacuum of space. Instead, it precisely matches the drive's internal operation to the Planck vacuum impedance at the Compton frequency.
So it essentially finds the natural baseline vibration rate of the universe and just hums along perfectly in tune with it.
Yes. And by doing that, the system theoretically achieves a Q factor, which is a quality factor of resonance, of approximately 10 to the 40th power.
Whoa, stop. 10 to the 40th. That's a 1 with 40 zeros behind it.
Yes, that is an almost incomprehensible astronomical amplification. It means for every tiny bit of energy you put into the HFGRs, the universe gives you a massive geometric pushback because you are perfectly in sync with its underlying fractal structure.
So what does that do to the actual fuel requirement? We went from Jupiter mass. Where are we sitting now?
We are down into the exajoule range, about 10 to the 18th joules.
10 to the 18. I mean, that's still a really big number.
Oh, it's huge. It's roughly equivalent to the annual energy consumption of the entire United States, or the output of a very, very advanced fusion reactor running full tilt. But here is the absolutely crucial key. It is finite.
It's an engineering problem.
Exactly. It's no longer turn the planet Saturn into pure energy. Now it's just build a really, really big battery. It moves the entire concept of faster-than-light travel from physically impossible to extremely difficult but technically solvable.
And that shift is just everything. Once something becomes merely an engineering problem, it's just a matter of time and budget.
Precisely. And that's exactly why this paper matters so much.
So let's zoom out for a second for everyone listening. What does this all really mean for us? We've gone from a hard Einstein says no to a firm maybe if we spin things really fast and hack the fractal depth of the universe.
It changes the map. If this metric engineering concept is real, it transforms fractal cosmology from a super niche mathematical theory into an actual practical blueprint for human interstellar expansion. We aren't just talking about building better rocket engines anymore. We're talking about torsion tunneling.
Torsion tunneling. I love that phrase so much.
It completely reframes how we view space.
Mm-hmm.
It implies that distance isn't a solid wall. Distance is just a variable. It's a line of code in the simulation of reality that we can just edit, provided we have the right password. And according to Nasanjargal, that password is spin.
It's fascinating to think that the ultimate barrier to the stars isn't a physical wall we have to smash through, but a frequency we just haven't learned how to broadcast yet.
And that the universe itself, this entire fractal universe, might actually be structured to allow this, like a hidden feature of the operating system that we are only just now stumbling upon.
That is a wild thought. We aren't breaking the laws of physics at all. We're just finally upgrading to the pro feature.
The developer mode of the universe.
Here's a final thought to leave you with, and this has been spinning in my head since we first started talking about metric engineering today. If we can literally engineer the metric of space-time using quantum spin, if we can edit gravity and edit velocity like we edit a typo in a Word document, what else in the universe becomes an engineering problem rather than a physical absolute?
That is the ultimate question, isn't it?
Are things like mass or inertia or maybe even time itself, are they just settings? Are they just parameters waiting for us to build the right wrench to adjust them?
If the universe truly is fractal and we actually learn to navigate those scales, then yes, the distinction between fundamental physics and basic engineering might just disappear entirely.
Something to really think about while you're stuck in traffic today, moving at very, very non-relativistic speeds. Thanks for diving deep with us into the geometry of the future.
A fractal universe awaits.
We'll see you on the next deep dive. Keep looking up.